Okay, so now we will do the introduction to calculus, where we will learn the fundamentals of why we require calculus in physics. The first thing is, why do we require calculus? The reason we need calculus is because calculus simplifies some complex paradoxes and indefinite concepts which cannot be defined in real life, like other substances or normal concepts. That is simplified using calculus. Two important concepts that we will simplify using calculus is first zero, and the second is infinity. To understand what is infinity, we will look up to a certain paradox. But before that, what is zero? We all know that zero is something that basically does not exist. So why do we write it on paper? What does that mean? It certainly means that there is some blank space that we want to represent with a zero. So zero does not exist in real life. You cannot say that you have zero things in your hand, which means nothing is in your hand. But still, in mathematics, we need zero to quantify the reasons behind the existence of those things. Now, one concept যেটা আমরা নিয়ে ডিসকাস করবো ফার্স্টে সেটা হচ্ছে ইনফিনিটি. One paradox is, let us assume that you want to go to your school from your home towards your school. Now, you start here and you say that you will cover 50% of the road left in 1 second. So, in the first second, let us assume that the entire distance is x. So, in the first second, you cover up x by 2 distance. In the second second, how much distance is left now? X by 2, because you have already covered the half of distance. So x by 2 is covered and x by 2 is left. Now 50% of x by 2 is x by 4, and how much is left? Still x by 4 is left. In the third second, similarly, you cover x by 8, which is 50% of x by 4. Similarly, you go on and on. But the paradox says that you cannot reach school in this method. But that is never true. This is not possible, because you can always uh, reach school in less than infinite seconds. If infinity is a concept that says that the that it is a concept which is even bigger than the biggest number you can possibly imagine. Okay, so lesser than infinity means any number is actually lesser than infinity. So if I say that you need 5 seconds to reach a school in a hypothetical case, or let's say 500 seconds to reach a school in a hypothetical case, infinity is always greater than that. If you say that you need infinite seconds to reach school, it means that you cannot reach school. But that is not true. You can reach school in much less than infinite seconds. So, how to handle this situation? This problem can be counter attacked using calculus. Okay, so in our study of calculus, we basically have some parts. The first part is Precalculus, where you have basically real numbers, complex numbers, trigonometry, coordinate geometry, and Euclidean geometry. Within real numbers, we have a lot of algebraic things, but we will cover them when we cover function. And the second topic is basically about function, but we will call that entire topic as foundation of calculus. Within this, you basically have functions and relations, vectors, limits, continuity, and bounds. After that, we will go to the third part, which is called as the derivative and integral. Within this, you have basically around 10 subparts. I'm not writing all of them now, but just for your notation, it has 10 subparts. And for the fourth one, we have its application in mechanics. So I believe you all know about real numbers. I will discuss about it in very short, in 5 minutes. I won't take much time for real numbers, and then I will move on to complex numbers. Any number then that can be quantified, any number that can be quantified or plotted in the Cartesian coordinates, plotted in Cartesian coordinates are real. Okay, any number that can be quantified or plotted in the Cartesian coordinates are real. So
Cartesian coordinate.
uh, you have learnt about the coordinate system where you have basically three axes x, y, and z. You have learnt about x and y. There, if you add a three dimension to it, a third dimension, we have z. You don't have the z part in your syllabus for the moment. You just have x and y, which certainly looks like this. These axes are basically lines that are reference lines that help us coordinate or rather plot any point in the graph. using coordinates. This was this was named as Cartesian coordinates. So if you
Oh,
consider a point x comma y, if this point can be plotted in a graph, then it is real.
okay.
Mhm. But it has to be a Cartesian. It has to be Cartesian coordinates, like the normal numbers that you use in daily life. Okay. To understand the next topic, before going to the next one, I would just give a uh, division about what are the types of real numbers. The first is rational and irrational. Within rational, we have decimals with non-zero numbers after decimal point, and decimals without non-zero numbers after decimal point. These decimals without non-zero numbers after decimal point are known as integer. Now, this might have confused you a little. Basically, there are two types of rational number. One rational number can be said as okay. So decimal with non-zero numbers after the decimal point can be like 2.5, 3.99, and so on, anything, etc. Now, decimals without non-zero numbers after decimal points are integers, which are like 7, 10, -1, -7. If you write any of these numbers in its decimal form, it is basically 7.0. There are no number after the decimal point for integers which have anything except 0. After the decimal point, it is only 0. Right? Okay. For integers, there is a classification. Also, you know that negative numbers, 0, and positive, which can be actually plotted in a line which we call the number line, which actually denotes the x-axis. So on the right hand side, we have positive, and on the left hand side, we have negative. At the center, we have 0. On the right hand side of center, we have positive numbers which go up to infinity, and on the left hand side, we have the negative numbers which go up to negative infinity. Now, both of you know about equations. So one thing about equations is when we take all the non-zero elements on one side, we can calculate the value of the unknowns. Always remember that number of unknowns in an equation, let us say that is basically equal to, suppose you have one unknown in the equation, let us say that is x. So you need those number of equations to find possible values of the unknowns. Now, what does that mean? এটা একটু মাথার উপর দিয়ে হয়তো গেছে। Let us say we have an equation. Let's say it is x plus 5 equals to 10. So what are the number of unknowns? 1. So you need only one equation to find the possible value of x, which is 5. You just needed this one equation to find the value of x. Let us say we have two equations, or sorry, two unknowns, x plus y equals to 9 and x minus y equals to 7. That means number of unknowns is 2. So you need two equations to find the possible values of the unknown variables. So from here you can actually, if you add these two up, you can find 2x is equal to 16, from where it comes x equals to 8. You put the value of 8 in equation, in any of the equations, you find the value of y is 1. So you needed two equations to find the value of two variables. If there are three variables, you need three equations. Now see the degree of these polynomials, all of them over here are 1. So number of solutions is also 1. Always remember, degree of polynomial is equal to number of possible solutions of that equation. Solution of an equation মানে এই যে আমি সলিউশন করছি, এর মানে হচ্ছে সলিউশন মানে হচ্ছে যে একটা ইকুয়েশনের যে ভেরিয়েবল থাকে এক্স বা ওয়াই বা জেড যা খুশি থাকে, সেই যে আননোন ভেরিয়েবলে কটা ভ্যালু স্যাটিসফাই করবে, মানে এই যে ভ্যালু গুলো না এক্স আর ওয়াই, এইগুলো তুই ইকুয়েশনে বসালে দেখবি যে ইকুয়েশনটা দুটো সাইড থেকে ইকুয়াল হয়ে যাচ্ছে। So we say that 8 and 1 are the solutions of x and y. Now if you have suppose x square plus 2x minus or let's say plus 1 is equal to 0, এটা আমি ঠিক আছে plus 1 equals to 0, জাস্ট একটা র্যান্ডম ইকুয়েশন লিখলাম। তো এর ডিগ্রি হচ্ছে 2, তাহলে এর যদি ডিগ্রি 2 হয় তাহলে পসিবল ভ্যালুজ অফ এক্স কিন্তু দুটো হবে। there will two possible values of x. যদি x to the power 3 থাকতো তাহলে 3 possible values of x. Any doubts?
No, sir.
Okay. The next thing that I am going to discuss over here is about complex number. Let us consider a certain equation x square minus 1 equals to 0 and another equation x square plus 1 equals to 0. What is the solution for x square minus 1 equals to 0? You can put x square equals to 1, which gives x equals to plus minus 1. Do both of you know what plus minus means? Plus minus just means that x has two values, 1 and minus 1. Okay. But what about x square plus 1 equals to 0? Here we will have x square equals to minus 1, which implies x equals to root over of minus 1. The root of minus 1 cannot exist in the Cartesian coordinates. It is not a real number and hence it is known as I or imaginary number. Now you can literally represent any number in terms of I. Give the heading complex numbers. First, firstly, we know that imaginary number I is equal to root over of minus 1. So what is I square? Root 1 into root 1, which is minus 1. So I cube is root 1 into I square, which is minus 1 into root over of minus 1, which is minus of minus 1. I to the power 4 is basically I square whole square, which means minus 1 whole square, which is 1. So these are some values you must remember. Now we have a general expression for complex numbers, which is x plus iy, where x is known as the real part and y is known as the imaginary part. How to represent it? Let us say, example, z is equal to 2 plus 3i. So 2 is the real part and 3 is the imaginary part. I'll give you another example. Let us say z equals to root over of minus 17. How to represent it? We can write this as 17 into root over of minus 1. So, sorry, root 17 into root over of minus 1. This implies, so this is root over of 17 I plus 0. So here the real part is 0 and the imaginary part is root over of 17. Is it clear to all of you?
স্যার সব ক্ষেত্রে কি i এর ভ্যালু রুট ওভার মাইনাস ওয়ানই হবে?
Yeah, I is defined universally as root over of minus 1 when it is referred as an imaginary number. In physics, I is represented as current, and that is why in physics it is represented as J, which is equal to root over of minus 1. It is universally accepted. In mathematics, I equals to root over of minus 1, and in physics, J equals to root over of minus 1. Okay? The reason is in physics, we define current in terms of I.
স্যার এই ভেরিয়েবলটা নেওয়া দরকার আছে, মানে আমরা যে কোনো কিছু ডিক্লেয়ার করতে পারি।
একবার
এই জে জে আর আই নেওয়াটা কি দরকার আছে? মানে কারণ এখানে বলে ম্যাথমেটিক্যালি যদি এ এ ইকুয়াল টু টু মাইনাস ওয়ান লেখা তো।
না ওরম না, তোকে আই দিতে হবে। ইন ম্যাথামেটিক্স ইউ হ্যাভ টু ইউজ আই, ইন ফিজিক্স জে। কিন্তু ইন ফিজিক্স তোদের এটা এক্ষুনি লাগবে না, ম্যাথামেটিক্সে আছে তোদের, ম্যাথামেটিক্সে আছে। তোকে আই নিতে হবে, তুই এ বি সি ডি নিতে পারবি না। কারণ কি বললাম, এটা ইউনিভার্সালি অ্যাকসেপ্টেড, এটা ইউনিভার্সালি অ্যাকসেপ্টেড যে এটাকে আই নিতে হবে ম্যাথসে আর জে নিতে হবে ফিজিক্সে। ফিজিক্সে তোদের লাগবে না, কিন্তু ম্যাথসে লাগবে, সেখানে তোকে আই নিতে হবে। ইউ ক্যানট চেঞ্জ দ্যাট। আর জেনারেল এক্সপ্রেশনে তোকে ওটা জেড নিতে হবে। এই যে জেড নিয়েছি না, জেড ইকুয়ালস টু এক্স প্লাস আই ওয়াই, তোকে ওটা জেড নিতে হবে। ওকে, সো we know that for real numbers we have Cartesian coordinates. Now what if we have to visualize a complex number? Then we will use something that is known as complex plane or Argand diagram, also called as Argand plane or Gauss's plane. এতগুলো নাম আছে। What does this mean? It is nothing but a representation in the graphical form where you represent the real part in the x-axis and the imaginary part in the y-axis, which means if you represent a certain point with x comma y, it represents z equals to x plus iy. Okay, but z equals to x plus iy may seem an equation to you, and you are right. It is an equation. Any complex number can be represented as an equation from origin, which is 0 0, also in case of Argand plane, till z. Okay, like this. Now you will ask, what should be the angle theta? This angle theta is known as the argument of complex number. In this case, this is the argument of z. Okay, what does this mean? How will we calculate theta? Theta, the relation between theta and z is argument of z. We represent it as arg z. It is basically theta, where tan of theta is equal to y divided by x. Okay, always remember that you have to calculate the argument from the positive x-axis, which means from x to the certain complex number z. Okay, next we will understand what is the absolute value of a complex number. The absolute value of a complex number is a representation in its real number form, which is root over of x square plus y square. X square plus y square. Okay, now always remember one thing, that the absolute value of any complex number is always a real number. Okay, because the values, individual values x and y, are real values. This imaginary part, real part, all these parts are real. The only thing that makes a complex number is I. Okay, so how will you find the absolute value of complex number? It is simple. This is basically the distance of z x comma y from origin 0 comma 0. Simple. You can find that using distance formula also. Okay. Due to our lack of time, I would not go into much uh, details of this complex number, but if we get time, we will do an extra class about this also. কারণ এটা আমাদের ইমিডিয়েট সিলেবাসে না থাকলেও এটা আমাদের ফিউচার সিলেবাসে আছে আর সেটা আমাদের করাটা উচিত। The next thing, as you can remember from this certain list, is trigonometry. In case of trigonometry, I think I have taken a number of classes to introduce it to both of you.
Yes.
Sumedha, do you know the basics of trigonometry?
Yes, sir. Like
Okay,
2-3 ক্লাস করেছিল।
okay. So I will go into some details of it. The first that I would like to go for, first give the heading trigonometry. I would not explain much stuff. I will just write some formulas. I think you know this basic formulas first of all, but still for revision, I am writing this. And these formulas are the most fundamental of all trigonometry. Okay, till this, all of you know. I don't think uh, like both of you know these important 7 formulas by heart.
Yes, sir.
Okay, so now I will also add some more few formulas which you need to know to do some important problems. The first one is sine of 90 minus theta is equals to cos theta. Cos of 90 minus theta equals to sine theta. Tan of 90 minus theta equals to cot theta. Also, sine of pi minus x is equals to sin x. Cos of pi minus x is equals to minus of cosec. Acha, remember pi is represented as 180 degree, 2 pi is equals to 360 degree, pi by 2 190 degree, pi by 4 is 45 degree. Also, pi by 3 is 60 degree, pi by 6 is 30 degree. Acha, also cos of pi by 2 plus x equals to minus of sin x, and sine of pi by 2 plus x equals to cos x. Now, how you will remember this? This is a very tough aspect for you initially. The only way to practice it is to practice doing sums. That is the only way. Also remember, 90 minus theta is actually called the complementary angle of theta, and pi minus x, where pi is 180 degree, pi minus x is known as the supplementary angle of x. Is this clear? 90 minus of the angle is complementary of the angle. 180 minus the angle, or pi minus the angle, is the supplementary angle.
Okay, sir.
There are basically innumerous number of formulas for trigonometry, but we won't go into those today. We will do it in other classes. The next thing that we're going to understand is about functions and relations. I have skipped Euclidean geometry and coordinate geometry because it is impossible to do them in one class. Euclidean geometry actually means the normal geometry that you have studied since class 5 or 6. Okay, because it was first invented by Euclid himself. And you all know now by this time what is coordinate geometry or the Cartesian geometry. Okay. The next thing is about functions and relations. First of all, any one of you tell me what is a set? What is a set? Okay, let me tell you. Sets are a collection of well-defined objects or elements that do not change from person to person. What does that mean? Consider a set of apples. If it is with you, let us say there is a set of 10 apples. If it is with you, it will still remain 10 apples. If it is with your friend, it will still remain 10 apples. Now the thing is, this can be considered as a set because it is a collection of 10 apples. 10 actually defines the number of objects. An apple is a well defined object. Okay, an apple does not change from person to person, so it is well defined. Now how to make it more well defined? You can also add it is a red color apple and not a green color apple. Okay, আমাদের এখানে যদিও গ্রিন অ্যাপেল সেরকম দেখতে পাওয়া যায় না অতটা, বাট ফরেনে পাওয়া যায়, so it's better to mention it. The more you define it better, the better it is. But let us say color, the color red. For you it is different, but for a colorblind person it is different. So it cannot be considered as a characteristic that can define the object to make it a set. To we denote set using curly braces. Okay, let us say set A. This is the notation. Example, let us say set A is 1, 2, 3, 4, 5. Always remember, if one element is seen twice or thrice or in a very repeated manner in a set, it is considered as one element only. Which means if you write 1, 2, 2, 3, 3, 3, 4, 4, 5, it is same as 1, 2, 3, 4, 5. Is it clear? Now there are some standard sets in math. First is the set of natural numbers. We represent it as this n with just a extra line, starts from 1, goes till infinity. The second is set of whole numbers. We represent it as w, starts from 0 and continues till infinity. Then we have set of integer, which is represented as a z. It starts from minus infinity, has all the negative numbers, includes 0 and all the positive numbers till positive infinity. Next, we have the set of rational numbers, which is denoted by q, which is equal to any number p by q where q is an integer. You can also represent this as q belongs to integer and q not equals to 0. Then we have set of rational irrational numbers. You represent it as q dashed or q complement, where it is Any x which is not rational, which does not satisfy the above condition for being rational. Last is the set of real numbers R, which is the union of rational numbers and irrational numbers. Okay, is it clear to all of you? Am I audible properly?
Yes, sir.
Okay. Now, I think you all know about the cardinal number of a set. What is the cardinal number of a set? It is also known as order of a set, which denotes total number of elements in a set without any repetition. Which means, let us say we have a set A which has these number of elements. So what is the cardinal number of a set or the cardinality of a cell? It is basically 5. Okay. Let us see, we have a set B. What is the cardinality of B? 4. Is it clear? Okay. The next thing that we are going to learn about are intervals. There are basically 4 types of intervals. The first type is open interval, which means it is a set of numbers from a lower boundary to a upper boundary. Okay. So for the case of open interval, we say the set x belongs to real number a less than x less than b is an open interval from a to b, which represents all real numbers from a to b excluding a and b. Okay, it is denoted using first bracket. Second type is closed interval. In case of closed interval, we define it as x belongs to a real number such that a is less than equal to x less than equal to b, which represents all real numbers from a to b, including a and b. Now there are two types of half open or half closed interval. Both are same, half open, half closed.
স্যার ক্লোজ ইন্টারভ্যালে থার্ড ব্র্যাকেট দেওয়া হয় না?
Acha, ha, correct. I forgot to mention this. For closed interval, you use third bracket. Correct. For half open and half closed interval, there are two types. For the first type, you have x belongs to real number, a is less than equal to x less than b, which is all the real numbers from a to b, including only a, not b, excluding b. Now, uh, for the second type, we have a less than x less than equal to b, which represents all real numbers from a to b, including only b and excluding a. To represent the first type, we use first bracket and then use, we use the third bracket and then use the first bracket. For the second case, we first use the first bracket and then use the second bracket. Okay, is it clear? Okay. In each of the case, the length of interval is basically b minus a. Okay. In case of closed interval, this is for open interval. In case of closed interval, it is b minus a plus 2. And in case of half open or half closed, it is b minus a plus 1. Okay. The next that we are going to understand is about what are basically unbounded intervals. All of these that you learned over here, these three types are bounded intervals. The next thing is unbounded intervals. If you have infinity on any side as a or b, replacing a or b or both, if you have infinity, it is called unbounded interval. Okay. Acha. You represent it as, let us say, a comma infinity, or let us say minus infinity comma a. It can be a comma infinity like this. It can be minus infinity comma a like this, or minus infinity to infinity. What does each of them mean? If, let us say, for x belongs to real numbers, for the first one, a to infinity means x is greater than a. For the second one, it means x is less than a. For the third one, it means x is greater than equal to a. For the fourth one, it means x is lesser than equal to a. And for the fifth one, sorry, I made a mistake that it won't be the second bracket, it will be first bracket. x is equal to r. Okay, basically r is represented with this. And always remember, you cannot put closed interval on infinity. The only reason is you cannot include infinity because infinity is just a concept and not any number. Okay, these are symbols, not real number. Okay,